Hello, grade 11 and grade 12. For sure by now, you know what we are doing here. It's mathematics. So today I want us to go through different questions of exponential functions. So I want us to do too much of these functions because functions is carrying a lot of marks in your final exam. So we have to do different questions of functions, and in today's class, you can see we are in a classroom. We'll be looking at exponential functions. So without waste of time, let me share my screen so that we go through those exponential functions. Okay, so let me just say from the current slide. I want us to look, or the first question we are going for is this one. Let me remove something, guys. Okay, let me put it down here. Okay, they are saying the sketched below is the graph of f of x equals to k to the exponent x. Let me pick a writing. Okay, the sketch below is the graph of f of x equals to k to the exponent x. F of x equals to k to the exponent x. So this graph that we see here, its equation, it's k to the exponent x. F of x equals to k to the exponent x, whereby k is greater than 0 and the point 4 and 16 lies on f. This is interesting. Now, okay, I won't be surprised if the first question says find the value of k. The first question can say find the value of k, because you can see we have got f of x equals to k to the exponent x. So k is the unknown there. For our question to be complete, for us to have a complete equation of the exponential function, we should know the value of k there. Okay, now we are given this point 4 and 16, and we are told that it lies on f. You can see it here. This point is indeed on the graph of f. It lies on f. So, okay, whenever this point lies on our graph f, it means we can go to this equation of f of x equals to k to the exponent x. Substitute our x with 4 and substitute our y with 16. So I can use this point as my x. I can use 4 as my x and use y as my 16. I have a right to use this point because it lies on the graph of f. Okay, so I can go to f and substitute this x and y on this equation of f. F of x equals to k to the exponent 16. I can actually say my f of x is 16 equals to k. My x is 4. I have a right to do this because this point lies on the graph of f. That's why I'm substituting on the equation of f. So one thing for sure here, I can be able to calculate k for sure. How? How can I calculate a? Normally in exponential equation, you want the base to be the same, or if possible, make the exponent to be the same. So 16 might be it might be something to the exponent 4. I wonder what is it? Something to the exponent 4 equals to k to the exponent 4. That's the question I'm raising. Can I write 16 as a certain number to the exponent 4? Why am I thinking like this? I want the exponent to be the same. So I'm tempted to say is 2 to the exponent 4. So let us check. What is 2 to the exponent 4? Is the same as 2 times 2 times 2 times 2. So it's 2 times 2, 4, times 2, 8, times 2, 16. Yes, 2 to the exponent 4 is 16. Now the exponent are the same. It means that k is equals to 2. Or another possibility, we could have set minus 2 to the exponent 4. Also minus 2 to the exponent 4, it's 16. This is possible. But in this case, we will say k is negative 2, which is not true because we are told that k is above 0. So the correct value of k, if they ask us to find k, it is 2, which is actually the first question on 5.1. It says determine the value of k. So it's simple stuff. How do you find the value of k? On your equation, f of x equals to k to the exponent x. Please substitute your y and your x so that k can be the only unknown on this equation. So when you substitute your x and your y, use a point which lies on the graph of f, because this is the equation of f. F of x equals to k to the exponent x is the equation of f. So use a point which lies on f. So I think I've already shown you how to get this 2 marks. Now, they are saying the graph of G is obtained by reflecting the graph of F. Okay. So you look on this. Okay. Let me raise first. I will explain. Okay. You look on the information, we are told a lot about the function f. We know actually that f, it is 2 to the exponent x. Remember, we calculated the value of k. We found that k is 2. So the function f, the equation of the function f is equals to 2 to the exponent x. So we are given a lot of information about the function f. Here, what they are saying here. They are saying the graph of g. We don't know much about g. What we see here, even this graph that we see here, is the graph of f. You see they wrote f here. This is the graph of f. Now they are saying the graph of g, which we don't know, which we don't have much information about it. The graph of g is obtained by reflecting the graph f. So they are saying you can do something to the graph f. Actually, you can reflect the graph f to find the graph of G, which is what we are going to do here. We're going to look at how can we find the equation of F. How can we find the equation of G using the equation of F? We are given the equation of F, which is 2 to the exponent x. So the question is, how can we find the equation of G using the equation of f? Okay, they're saying the graph G is obtained by reflecting the graph of f about the line y equals to x. So they are saying, okay, to find the graph of G, use the graph of f. Use the graph of f to find the graph of G. What is it that you must do to the graph of f? You must reflect it along the line y equals to x. Okay. Now, okay, let us find the equation of G. What do we have? We have the equation of f, which we believe we can use it to find the equation of G. How are you going to use f to find the equation of G? We are going to reflect the equation of f about the line y equals to x. This is what the examiner says. Says reflect f about the line y equals to x, and you will find the equation of G. So let's do that. Let's reflect f. The first thing that we do, we write that equation f, which is y equals to 2 to the exponent x. This is the equation of f. I said f of x is the same as saying y. So y equals to 2 to the exponent x. So we reflect it about y equals to x, which simply says swap your x and your y. When you reflect about the line y equals to x, you're going to simply swap your variables. So where there is y, you are going to put x. So you say x. Where there is x, you put y. So you say y. So that's what you have done. You have reflected about the line y equals to x. So the equation of G, Now, okay, before I even talk about remember, I'm trying to find the equation of G by reflecting F. How? By reflecting F along the y equals to x, which means swap x and y. So I've swapped x and y. I have x equals to 2 to the exponent y. And I will say this equation here, x equals to 2 to the exponent y, I don't like it. My experience says this one should not be liked because we prefer to make y the subject of the formula. So I have x equals to 2 to the exponent y. And guess what? I'm going to say, no, on this x equals to 2 to the exponent y, I have to make y the sub of the formula, which is now we are talking about something very interesting. Now I will say, what is written in exponential form? X equals to 2 to the exponent y is in the exponential form. What is written in the exponential form can be written in the log form, okay? And we know that when we write it in the log form, y will be the subject of the formula. So how do you do it? You have x equals to 2 to the exponent y. You want to write it in a log form. You see your base. Your base is 2. This is base. Y is your exponent. So what you do, you go to the base. On this right side to the base, you just put log. You say log of this. Ne? Now you swap x and y again. Where there is x here, you put y. Where there is y here, you put x. So now you have y equals to log x base 2. Y equals to log x base 2. So this is the equation of G. Now you say, where there is y, you say, I'm talking about G. You say G of x equals to log x base 2. Interesting. So actually, when we ask you to reflect along the line y equals to x, we are asking you to find the inverse of a function. So if you are given f, you are told that f of x equals to 2 to the exponent x. You are given the function f, and you are asked to reflect it along the line y equals to x. So when you reflect f along the line y equals to x, you are actually looking for the inverse of f. So on 5.2, this examiner is looking for the inverse of f, which is f to the exponent negative 1. So he's simply saying the function g is the inverse of f. So give us the equation of g. Give us the equation of the inverse of f. Okay, I'm saying it for the last time. If I say to you, reflect the function along the line y equals to x, I'm simply looking for the inverse of that function. So you get your 2 marks here. Okay, now we're going to 5.3. Sketch the graph of G. I love this maths. I love this math. This is a very good, this examiner brings some good stuff, because now the function f is drawn for you. The exponential function, it is drawn for you. You have the expo function, which is being drawn. And they want you to sketch the graph of G, which is the inverse of f. They want you to sketch the inverse of f. And you realize that it's interesting. The way I sketch the graph of G, which is the inverse of f, is going to be more simpler. I don't think when I was doing grade 12, it was simpler as it is now. When I was doing grade 12, I will still be able to sketch the graph of the inverse, but I think I was taking the longer approach. Now, because my math has improved, okay, it will be more easier to sketch the graph of the inverse. Watch out. Look what I'm going to do. I'm going to say on the function f, I have the point 4 and 16. Which means that on the function g, which is the inverse of f, I'm quite sure on the function g, I have a point 16 and 4. So it was simply a matter of swapping your coordinates. So you are saying if you have a point on the original function, it means that the point on the inverse is going to be a matter of swapping your coordinates 16 and 4. Now I have another point which is 0 and 1, the y-intercept on F, this point here. It means now the point on G is going to be 1 and 0. Now, the function F, remember this one, it is the exponential function. So it has what we call, it has got only one asymptote. The exponential function has the asymptote. And that asymptote, it is only one. And what is this asymptote? It is what is this asymptote? It is the y asymptote. The asymptote of this exponential function, it is the horizontal asymptote, the y asymptote. There is an asymptote here passing. You don't see the asymptote because it's seated on the x-axis. A dotted line seated on the x-axis, you don't see it. But look carefully on this exponential graph f. It does not touch the x-axis. It only approach the x-axis. So we are saying there is an asymptote there. That is why our graph is not touching the x-axis. And what is the equation of this asymptote? The equation of this asymptote, it is y equals to 0. Guys. The exponential function has got only one asymptote. The asymptote of y, which is the horizontal asymptote. So let's say, suppose we had this kind of equation. Let's say we had f of x equals to 2 to the exponent x minus 1. What was going to be our asymptote there? F of x equals to 2 to the exponent x minus 1. Your asymptote was going to be negative 1. The y asymptote in this case is negative 1. So the number at the end here represent our y asymptote on the exponential function. So the y asymptote of this one was going to be negative 1. And as y equals to negative 1, the asymptote, we were going to show it with a dotted horizontal line passing at negative, where y is negative 1. So in this case, because we simply have 2 to the exponent x, we don't have any number here at the end. We say actually the asymptote, it is 0. We see 0 here. So what is the equation of the asymptote of f of x equals to 2 to the exponent x? It is y equals to 0. And this, the asymptote of y equals to 0, when you show it on the graph, it is seated on the x-axis. So that is why we don't see it here. It is there. If I raise here, you don't see that there is this exponential function has got the dotted vertical line because it's exactly on the x-axis. Okay. Now, if the exponential function has the y asymptote, it means its inverse will have the x asymptote. The inverse is actually a logarithm graph. The inverse of the exponential is a logarithm. So f of x is the exponential. G, the inverse of f, is a logarithm graph. So the exponential graph has the y asymptote, which means that the logarithm graph will have the x asymptote, and the x asymptote of this graph that I'm sketching, it is 0. It means that this asymptote will pass the x-axis at 0. 0 is here. So the line will be like this. So I already know that this graph of G that they want me to sketch will not touch the y-axis. Okay, now I know the point or one of the point on the graph of G, it's 16 and 4. So I'm going to check where x is 16. Carrying 16 maybe somewhere here. I'm lazy. Then we have 16 and we have 16 and 4. X is 16, y it's 4. So 1, 2, 3, 4. So let me say I will match this point 16 and 4. Put it here. And I will also have 1 and 0 where x is 1. Put it here. 1 and 0. It's here. 1 and 0. You can tell that that is the x-intercept. It has to be on the x-axis. So the graph appears to be like this. I know it won't touch the y-axis. Yes, something like this. Note that in your exam, they are going to give you a Cartesian plane to sketch your graph. So this one, it appears a bit ugly because not drawn to scale. My actually here my focus is just exposing you on how to sketch it. I'm not trying to be perfect here. What you have to know is that the graph, this graph of G, actually name it, this graph of G will not touch the y-axis. The exponential graph was not touching the x-axis. The logarithm graph in this case, the inverse of the exponential will not touch the y-axis. How did I find the coordinates? I just swapped the points. Look how simple actually I did this. It's very simple. Now, here, I know actually there is a line y equals to x because this f, actually G is the reflection of f along this line, y equals to x. So how do they give 4 marks here? I think they will mark a shape. They will mark this point. Okay. The shape, the point. How do they even give 4 marks? They will mark the idea that you can see that the graph does not touch the y-axis, the idea of the asymptote. And maybe the fact that you know that this point is 16 and 4. But the way, exactly the way I've sketched the graph, there is nothing wrong. You'll get your full marks, 4 marks. But make sure that you show the x-intercept 1 and 0. Make sure that you name your graph. Give us the correct shape of the graph. So this 4 marks was easy. Sketching the graph of the inverse, it's very easy, guys. Just use the information from the original graph. Use the function f to sketch the inverse of f. Now, yeah, indicate on your graph the coordinates of the 2 points on G. Oh, I have to, this point here, just indicate it. Just say 16 and 4 and indicate this point here, 1 and 0. I think that's why they say 4 marks. Now they say use your graph to determine the values of x for which f times g is greater than 0. The key word, and now these are very interesting questions. Most students find these ones to be complex. They are saying 5.4.1, they're saying use your graph to determine the values of x. They are looking for the values of x for which f times g is greater than 0. Okay. For f times g to be greater than 0, meaning they are looking for the product of the function f and the function g. They are saying if we multiply these two functions, f and g, the graph and its inverse, what are the values of x whereby their product will be above 0? Okay, let me raise, I will explain this idea very well. So we say, okay, we know that f of x times g of x is greater than 0 if when f of x is negative. When f of x is negative, maybe if we have the negative uh, value of y from f, okay, f times g is greater than 0 if when f is negative, g must also be negative. Must also be negative. Why? Why am I saying this? The only way we can get the number which is greater than 0 is when we multiply negative with negative. So when f is giving us the negative y value, even g should give us the negative y value. So if we multiply negative with negative, we will get a positive answer, and the positive answer is above 0. Or another possible way in which we can get greater a value above 0 when we multiply these two, it's when f is positive and g is also positive. If we multiply positive with positive, we will get the answer which is above 0. So now, this means that when f is below the x-axis, remember f is negative below the x-axis. When f is below the x-axis, even g has to be below the x-axis. And sorry, we see f actually, we don't have any x values whereby f can be below the x-axis. Look at the graph of f here. It's always on top of the x-axis. Remember, we even said it won't touch the x-axis. This graph f will always be on top. It means that f is always positive. The function f is always positive. For all values of x, f is always positive. So the only way we can multiply f and g and get a positive answer, it's when f is positive and g is also positive. From this scenario, we see that f is always positive because it's always on top of the x-axis. It means now the only way when we get the values the only way when we get the product that is above 0, it's when the function g also is above the x-axis. G is forced to be above the x-axis so that when we multiply f and g, we get the number above 0. So g is forced to be above. F is above, we can see all the time f is above. So g must also be above the x-axis. So now we see that from this point here, going there, g is always above the x-axis. So when x is greater than 1, g is always above the x-axis, meaning that if we were to multiply f and g at any value of x above 1, when x is greater than 1, if we were to multiply f and g, we will get the answer which is greater than 0. So when it's f times g greater than 0, when x is greater than 1, x must be greater than 1. Yes, so the answer here is x is greater than 1. We give you 2 marks. Now they are saying, for which values of x will g be below and equals to negative 1? For which values of x will g be below and also be equivalent to negative 1? So let us look at the value of y, which is negative 1. So we have got 0 here. Y is negative 1 here. So I'll draw a line here. It's not an asymptote. I will just draw a line which passes y at negative 1. So it means, for example, okay, Yes, this is the line where y, this is the line of y equals to -1. So they are asking, what are the values of x whereby your function g will be below this -1? So we are looking, we want to know when will, okay, what are the values of x whereby the graph itself, the graph g is below -1. I think I have to draw a neat graph so that I can be able to explain this. Let me, okay, let me raise this interesting question as well. It's not difficult, guys. Y is -1 here? So, and the graph is something like this. We know that actually this graph of G does not touch the Y axis. So actually, so from G, there is no way X can be, the values of X cannot even be below 0. Okay? The values of X cannot be below 0 because the graph, it's always this side, it's always on the right side of the y-axis. It does not go to the left side. It's always this side. The graph of G is always this side because we are saying the graph of G cannot touch the y-axis, cannot go to the other side. So the graph of G is always giving us the value of x which are above 0. For the function G, actually, if I was to say to you, give me the domain of G, you'll say x is above 0. All values of x are above zeros. Now, but here we want to know the value of x whereby the function itself is below -1. So let me ask this question. When y is -1, what is the value of x? I'm looking at the function g. Do you still remember the equation of g? We had y equals to 2 to the exponent x. And I said the equation of g is log x base 2. This is the equation of g. But you can think of it as x equals to 2 to the exponent y, because I don't prefer to work with it when it's in a log form. I prefer to work with it when it's in the exponential form. So this guy, g of x equals to log x base 2, is the same as x equals to 2 to the exponent y. This is the same thing. It's written differently. Now, I'm saying when y is -1, what is the value of x? You can compute it very easy. You can say x equals to 2 to the exponent -1. I'm saying when y is -1. So x, it's 1 over 2. You can press it 2 to the exponent -1, it's 1 over 2. So on the function g, we have a point here, which is 1 over 2 and -1. So we are saying on a point on a function g, when x is 1 over 2, y is -1. So now what are the values of x where the function g is below this line, below the line of -1? It's when x is less than and equals to 1 over 2. So the answer here is when x is less than and equals to 1 over 2. So it was another interesting question as well. Actually, this question, guys, it's very, very interesting. I wish I had looked before which previous paper is this one. I know I had screenshot this question from one of the previous question paper, but unfortunately, I don't know which one it is. So what I'm going to do when I'm posting this on YouTube, before I post it, I will specify on my thumbnail which question, which previous question paper is this one. This was the very interesting question. Get it? I hope this video I hope you are able to get this video. It's amazing. The question is amazing. Make sure that you understand everything. Ask me questions where you don't get, because this is a very interesting question that can teach you a lot about the function, the exponential function and its inverse. This was an interesting question. Okay, let me see if this question was actually continuing. I want to check if it's continuing. Okay. Oh, that's another question. Okay. That's another question. I'll just stop here and see you next time. See you guys. God bless you.